Hey everyone, welcome back to the Incredible India podcast series. I'm your host, Sam, and sitting right across from me is our resident expert, Taylor.
Hey there. So glad to be here for this one.
Yeah, me too. So I want you, the listener, to just imagine walking through a heavy monsoon downpour in Delhi. You step into a courtyard and you see this 23-foot tall iron pillar.
Right, just completely exposed to the elements.
Exactly. And it has been standing in the rain for over 1,600 years. By all known laws of modern metallurgy, it should literally be a crumbling pile of red dust by now.
Oh, absolutely. It should be gone.
But instead, the metal is pristine, untouched by rust. And that is just one of the anomalies we're digging into today for this deep dive.
Yeah, it completely shatters that linear timeline of human progress we're usually taught in school. We're exploring a stack of historical records, metallurgical analyses, and acoustic research today. Right, because our mission for this deep dive is to shortcut your path to being well-informed on this. We want to show you 10 ancient Indian engineering mysteries that completely baffle modern scientists.
And I promise this won't be a dry list of facts.
Definitely not. We are going to explore exactly how these ancient builders pulled off feats that today's engineers, with lasers and 3D modeling, still struggle to replicate.
Yeah, we're talking about everything from the sheer scale of their architecture all the way down to microscopic precision. So the most logical place to start is the macro level.
Right, the manipulation of solid rock.
Exactly. Specifically at the Kailasa Temple in Ellora. Because when you or I think of construction, we picture a foundation being poured and a building going up, brick by brick.
Building upwards.
But the architects at Ellora did the exact opposite. They carved a multi-story, hyper-detailed temple complex out of a single mountain of solid basalt rock.
They didn't build up, they literally excavated downward. It's like watching a massive reverse 3D printer working directly into the bedrock.
That's a great analogy, actually. And the volume of material is just staggering. They removed an estimated 400,000 tons of solid rock.
Which completely breaks my brain, mostly because of the permanence of the medium, right? When you are carving top down into a monolith, you have zero room for error.
None at all.
Like one bad strike with a hammer or one misjudged fracture and a load-bearing pillar is just ruined forever. You can't just glue a mountain back together.
You really can't. Which implies this unbelievable mastery of three-dimensional spatial visualization.
Yeah.
Before a single chisel even struck the mountain, the master architect had to hold the entire structure in their mind.
Every stairwell, every carved elephant.
Yes. Modern engineers look at this site and estimate that orchestrating a top-down excavation of that scale today would require advanced CAD software, to calculate structural integrity as the rock is hollowed out.
And they did it over 1,000 years ago with math we still haven't fully decoded. Well, speaking of math we haven't decoded, we have to talk about the Brihadiswara Temple because it presents a totally different gravitational puzzle.
Oh, the capstone. Yeah.
Right. This temple is capped with a massive granite stone weighing roughly 80 tons. And it's sitting dead center at the top of a tower, literally 200 feet in the air.
Placed there centuries before hydraulic cranes or motorized lifts were even a concept.
Okay, but let me play devil's advocate for a second here. Human beings have been moving massive stones for millennia. Couldn't they have just built like an enormous earthen ramp to drag the stone up and the ramp just washed away over time?
Well, that's actually the most common hypothesis.
Mm-hmm.
But the physics of that ramp quickly become impossible when you run the numbers.
Really? How so?
So to achieve a manageable incline, say 6 to 8 degrees, to drag an 80-ton block, that earthen ramp would need to be over a mile long.
Wow, a mile-long ramp.
Yeah, and a structure that massive requires millions of tons of packed dirt. Compacting that much soil leaves a permanent geological footprint on the landscape.
Oh, I see. So we would be able to test the soil today and actually see that a ramp used to be there.
Precisely. And there is absolutely zero geological evidence of ramp compaction anywhere in the surrounding area.
So they definitely didn't use a mile-long ramp.
No. The total lack of evidence suggests they had a deep understanding of weight transfer, maybe interlocking counterweights, or some modular timber lifting technology that bypassed brute force physics entirely.
That is wild. And honestly, it gets even more baffling when you look at the Konark Sun Temple, because the mastery isn't just in lifting heavy things, it's in microscopic precision.
The joints between the blocks.
Yeah. The massive granite blocks at Konark fit together with tolerances of less than 0.1 millimeters. That is sealed so tight you literally cannot slip a piece of paper between the stones.
And they did all of that without mortar. Modern laser measurements show that achieving this level of flush joining today basically requires computer-controlled milling machines.
So how do they do it? Obviously, they didn't have diamond-tipped circular saws lying around.
No, they didn't. The leading theory among structural archaeologists is a process called abrasive kinematics.
Abrasive kinematics. Okay, what is that?
So instead of cutting the rock perfectly, they would suspend one massive granite block over another and then introduce a slurry of water and highly abrasive corundum sand between them.
Oh, and then just rub them together.
Essentially, yeah. They used enormous leverage systems to grind the two stones against each other. Over weeks, the stones would naturally wear each other down into a custom-mated, totally frictionless seal.
That requires an agonizing amount of patience.
It does. But it creates a joint that is virtually earthquake-proof because the stones are locked into one another's microscopic grooves.
Wow.
Yeah.
Well, that perfectly transitions us into how they manipulated the internal structure of the stone itself. They weren't just grinding rock, they were engineering it to manipulate invisible forces.
Like sound waves, right?
Exactly. Which brings us to the Hampi musical pillars at the Vitala Temple. We are talking about 56 solid granite columns that, when you tap them gently, produce pure musical notes.
And it's important to note, these aren't just random, clunky ringing sounds. They are tuned perfectly to specific traditional Indian musical scales, known as ragas.
Right, like striking different pillars produces the distinct tones of stringed instruments or bells or even percussion. But this is where the mechanics completely stump me.
Because of the resonance chamber issue.
Yes. Think about an acoustic guitar or a flute. Modern acoustics basically relies on a hollow resonance chamber to amplify sound. How on earth do you tune a solid block of dense granite?
That is the exact paradox that acoustic engineers struggle with today, The secret lies in the artisan's ability to manipulate the granite's internal stress patterns.
Internal stress patterns, meaning the stone isn't uniform.
Exactly. Granite is a crystalline structure made of quartz, feldspar, and mica. The ancient builders figured out how to map the density of a raw piece of stone.
So they knew where the dense spots were before they cut.
Yes. And by selectively carving away material at very specific geometric points along the pillar, they could alter the natural wavelength of the vibration traveling through the rock.
They were essentially finding the natural acoustic nodes inside the rock and releasing them.
That's spot on. They understood that you don't need a hollow chamber if you can force the solid mass itself to vibrate at a highly controlled frequency. It's a profound understanding of material resonance.
It's literally turning a mountain into a symphony. And, that acoustic engineering scales up massively when you look at their whispering galleries.
The Gold Gumbaz is a perfect example of that.
Right. It has a massive dome where a whisper travels 124 feet and can be heard with crystal clarity on the exact opposite side. But if you stand in the middle of the room, you hear nothing.
Yeah, and if you look at famous whispering galleries in Europe, like St. Paul's Cathedral, they usually rely on simple circular geometry where sound just hugs the wall.
So what did the builders of Gold Gumbaz do differently?
They utilized a much more complex parabolic curve, which creates highly specific focal points. Plus, they formulated a unique plaster for the dome, laced with specific mineral aggregates.
Like a hard acoustic mirror.
Exactly. It reflects the sound waves with almost zero energy absorption.
That's incredible. And the Chidambaram temple takes this up another notch, right? By acting as a giant stone acoustic filter.
It really does.
I like to think about the noise-canceling headphones you might wear on a plane.
Yeah.
Those use microchips to invert sound waves and cancel out engine hum. But at Chidambaram, they achieved selective frequency filtering using only carefully arranged air gaps.
Yeah, it works on the principle of Helmholtz resonance. The temple features a specific arrangement of stone columns and hollow spaces in the roof.
So the gaps act like the neck of a bottle when you blow across it.
Precisely. They are mathematically proportioned to trap and absorb chaotic high-frequency background noise like the murmurs of a large crowd.
Oh, wow.
And at the same time, the dense stone layers are perfectly spaced to amplify the specific, resonant harmonic frequencies of a human voice chanting in Sanskrit.
So they literally built an architectural equalizer out of stone.
They did.
It's brilliant. And they applied this same mastery of invisible forces to thermodynamics, too, like the Chanbauri stepwell in Rajasthan. It drops 100 feet into the earth via 3,500 incredibly narrow, perfect steps.
And the temperature difference is just staggering.
Right. On the surface, the desert temperature in Rajasthan can easily hit 120 degrees Fahrenheit. But at the bottom of the stepwell, the air remains consistently, comfortably cool year-round.
It acts as an ancient electricity-free air conditioning system. The mechanism relies on the thermal mass of the stone and the latent heat of vaporization.
Okay, break that down for us. How does a massive stone pit cool the air?
Well, during the searing heat of the day, the massive volume of stone blocks absorbs the solar radiation, keeping the ambient air cooler. But the real magic is the water at the bottom.
Because it evaporates.
Exactly. As that water slowly evaporates, it undergoes a phase change from liquid to gas. That phase change requires energy, which it pulls as heat from the surrounding air.
Meaning it rapidly cools the air at the bottom of the well.
Right. And because cold air is denser and heavier than hot air, the inverted pyramid shape of the stepwell traps that dense, chilled air perfectly in the lower levels.
So they engineered a permanent, self-sustaining microclimate using nothing but geometry, stone, and water.
It's elegant, really.
It is. Now, if building giant Earth-powered air conditioners and tuning solid rock sounds impossible, wait until we cross into ancient nanotechnology.
This is where things get really wild.
Yeah, this brings us back to the Iron Pillar of Delhi we talked about at the very beginning, the 1,600-year-old pillar that refuses to rust.
Right. Most iron from that era would have oxidized into powder centuries ago.
Especially since the pillar has no paint and no protective coating. So how is it surviving the humidity and monsoons?
Modern metallurgical analysis actually finally cracked this. The ancient smiths didn't just smelt iron. They engineered a very specific chemical alloy.
What was in the blend?
They used a high phosphorus iron blend, but crucially, they didn't burn away all the impurities. They managed to distribute microscopic particles of slag, which is basically a glassy byproduct of smelting uniformly throughout the metal.
Wait, so they intentionally left impurities in the metal?
Yes. When this specific high phosphorus slag-rich composition is exposed to moisture, a chemical reaction occurs. It forms a microscopic crystalline layer called misoite.
And that layer protects it.
Highly resistant to corrosion. Essentially, the pillar rusts exactly once, at the microscopic level. And that initial rust forms an impenetrable, self-healing armor that permanently seals the rest of the iron away from oxygen.
A self-healing metal. That is just wow. And the nanotechnology goes even deeper with the legendary Wootz steel, right? Which most people know as the original Damascus steel.
Oh, the blades, yes.
Yeah.
Famous across the ancient world for being incredibly sharp and flexible.
Right. But when modern scientists put antique Wootz steel under an electron microscope, they found something that literally shouldn't exist in the ancient world. Carbon nanotubes and carbide nanowires.
And just for context, modern science didn't officially discover carbon nanotubes until the late 20th century. There are these cylindrical molecules of carbon that are incredibly strong.
So how do you accidentally invent nanotechnology in an ancient forge?
You don't do it accidentally.
Mm-hmm.
You do it through a highly controlled, incredibly mysterious crucible process. The ancient Indian metallurgists would seal specific iron ores in clay crucibles, along with highly specific carbon sources.
Like what kind of carbon sources?
Things like the wood and leaves of the cassia plant.
Yeah.
They would fire these crucibles for days at very specific temperatures.
Oh, I see.
The plant matter would release carbon atoms that, under that exact pressure and thermal cycling, naturally crystallized into microscopic tubes and wires, woven directly into the steel's matrix.
And it wasn't just metal where they applied this either. They applied this deep chemistry to art. Look at the Ajanta Cave paintings.
The 2,000-year-old murals on the cave walls.
Exactly. They have survived centuries of crushing humidity and insect activity without losing their vibrant color. And chemists recently discovered they use nanoscale iron oxide for the pigments.
And what's fascinating is how they bound that pigment to the rock. Because they didn't use animal fats like European painters did. They used specific organic plant saps and gums.
Which created another self-healing mechanism. When the atmospheric humidity in the caves fluctuates, it actually rehydrates those organic binders just enough to let the pigment subtly flow.
Right, it fills in microscopic cracks before they can spread.
The paint literally uses the humid air to repair itself.
It's incredible, and we see that same biological approach in their earthquake-resistant mortar, too.
Oh, right. The mortar holding together structures like the Brihadiswara temple.
Yeah, it isn't just mud and burnt lime. The builders blended in rice starch, jaggery, which is unrefined cane sugar, and egg whites.
Honestly, that sounds like a recipe for a very dense cake. Not something you'd use to hold a skyscraper together.
It does sound like a bakery recipe, I know. But chemically, adding those long-chain proteins and sugars creates flexible biopolymers.
So it's not brittle like modern concrete.
Exactly. Standard modern concrete is incredibly strong, but if the ground shakes violently, it snaps. The organic mortar used in these temples exhibits viscoelastic behavior.
Meaning it acts like, silly putty.
Pretty much. Under normal conditions, it is solid. But when hit with the sudden massive kinetic energy of an earthquake, the biopolymers allow the mortar to flex and stretch on a microscopic level,
It acts as a seismic shock absorber.
dispersing the energy rather than shattering. That is why these temples remain standing while modern concrete structures nearby just crack.
Okay, we need to pause here because this raises a massive question for me. If they possess the recipes for self-healing, rust-proof iron, carbon nanotubes, and earthquake-proof biopolymers, how did humanity lose this?
It's a great question.
Like, how does knowledge this advanced simply vanish?
Well, it comes down to how knowledge was transmitted back then. Creating wood steel wasn't a formula you could just write down in a book. It was highly localized and deeply experiential.
Meaning you had to learn it by doing it.
Exactly. It required specific trace minerals from particular local mines. The thermal cycles lasted for days, and the temperature had to be judged purely by the glowing color of the metal.
Which takes decades to master.
Right. So the master-apprentice chain was everything.
So when colonial forces or changing empires disrupted those local systems, the knowledge pipeline just snapped.
Precisely.
Hmm.
Western metallurgists tried to replicate the steel using their own standardized European methods, and they failed completely because they lacked the specific organic additives and the localized knowledge.
That makes perfect sense. Once the masters passed away without training the next generation, the tech was just lost to time.
Tragically, yes.
Well, we've explored their mastery over earth, over sound, over chemistry. Let's zoom out now. Because these engineers didn't just look down into the earth, they looked up.
They connected their earthly structures to celestial mechanics.
Yes, and the Jantar Mantar in Jaipur is probably the purest example of this. It houses the Samrat Yantra, which is the world's largest stone sundial.
And when you say sundial, people probably picture a little garden ornament.
Right, but this is a 73-foot-tall geometric monolith that measures time to an astonishing 2 seconds of accuracy. 2 seconds.
And it does this by completely syncing with the Earth's orbital mechanics. To achieve 2-second accuracy, the gnomon, the massive triangular wall casting the shadow, is angled perfectly at 27 degrees.
Which exactly matches the latitude of Jaipur.
Exactly. But the real genius is the curved marble scales where the shadow falls.
Right, because if the scale were flat, the shadow speed would distort depending on the time of day and the time of year.
You've got it. The architects calculated the Earth's axial tilt and built curved quadrants that perfectly intercept the shadow at a constant rate.
Completely neutralizing the distortion caused by the sun's seasonal path across the sky. The geometry automatically adjusts for the changing seasons.
It's astonishing, and they map the stars just as accurately. The Khajuraho Temple complex functions as a massive astronomical observatory, basically hidden in plain sight.
Oh, so?
The spacing and positioning of the individual temples aren't random at all. They are aligned to track the 8-year orbital cycle of the planet Venus.
Wow.
Furthermore, during the winter solstice, the main temple perfectly aligns with the constellation Orion. The proportional distances between the shrines even scale to the distances of the outer planets in our solar system.
So they were encoding complex astronomical data directly into their floor plans.
They absolutely were.
Which brings us to the most controversial part of our research today, because when you talk about ancient India and the sky, you inevitably run into the Vimanas in the Lapakshi temple.
Right, the ancient texts.
Yeah. Ancient Sanskrit texts, specifically the Vaimanika Shastra and parts of the Ramayana, describe advanced flying vehicles called Vimanas. And the texts don't just use poetic language about chariots of the gods.
No, they don't.
They provide incredibly dry technical descriptions of lightweight metallurgy, mercury-based propulsion systems, and anti-gravity. So, are we talking about genuine ancient airplanes here, or is this just mythology?
Well, looking at this impartially, we're not saying we have proof of ancient airplanes, but what is fascinating from an engineering standpoint is that these texts contain technical blueprints that parallel real, measurable physical anomalies in their architecture.
Like the floating pillar at the Lapakshi temple.
Exactly. The best example.
For those who don't know, this is a massive, incredibly heavy stone pillar that does not rest fully on the ground. You can literally slide a piece of cloth completely underneath it. So is that genuine anti-gravity or just clever weight distribution?
When modern geologists analyzed the stones used at Lapakshi, they found they contain an unusually high iron content. So the current working theory isn't magic, it is magnetic levitation.
Magnetic levitation.
Yeah, the ancient builders arranged these specific iron-rich basalts in a way that their localized magnetic fields violently repelled each other.
They were manipulating magnetic fields to push upward against the dead weight of the stone.
Precisely. They discovered magnetic levitation thousands of years before maglev trains. They used the natural magnetism of the Earth to negate gravity.
Man, if we synthesize everything we've looked at today, from the top-down rock carving of Ellora to the nanoscale pigments of Ajanta, down to the magnetic pillars of Lapakshi, the key takeaway is really one of deep integration.
It is. Ancient Indian engineering did not separate art, religion, mathematics, and physics into separate silos like we do today. They built holistic environments.
Right. A single granite building served as a place of worship, an accurate solar calendar, a natural air conditioner, and an acoustic frequency amplifier, all at exactly the same time.
They didn't build machines to fight nature. They arranged raw materials so that the laws of nature did the work for them.
It completely reframes what we consider advanced technology.
It really does.
And it leaves you with a profound question, I think. Today, we store our greatest scientific breakthroughs on incredibly fragile silicon chips and server farms. If a massive solar flare wiped our digital data tomorrow, what physical structures would we leave behind to prove our technological brilliance to the people living 2,000 years from now? Would our glass and steel skyscrapers last even a fraction as long as a self-healing iron pillar or a carved granite mountain?
It definitely puts our modern achievements into perspective.
If you decide to travel to India, we have a recommendation. Five Senses Tours organizes tours across India, which are immersive cultural experiences. You can email contact@fivesensestours.com. Note 5 is written as a numeral and contact@fivesensestours.com. Or WhatsApp to +919 845 677 446.